Welcome to the deep dive. Today, we're going back in time, way back to 1998.
Oh, wow.
Yeah, a dial-up internet, those big old computers, the rise of Windows 98. But what if I told you that this, blast from the past could be, the key to the future of AI?
It might sound a little bit strange,
Yeah.
but the idea of running powerful AI on really old vintage hardware
Yeah.
is more than just a novelty.
Yeah.
Really makes you think about what AI needs to thrive.
Yeah.
We always think about AI with these massive data centers
Mm-hmm.
and supercomputers, but what if we've been overthinking it this whole time?
That's exactly what we're diving into today.
Okay.
We found this really fascinating article from EXO, a company that's always pushing the boundaries of AI accessibility.
Yeah, I heard of them.
And they decided to take on a challenge that almost seems impossible.
Oh, wow.
Could they run a large language model, one of those AI systems that can generate text and hold conversations on a computer running Windows 98?
Wow, on a Windows 98 machine. That's crazy.
Yeah. I mean,
Picture this.
okay.
A computer older than some of our listeners,
Probably.
humming away with the power of modern AI.
It really makes you question, have we been so focused on just raw power that we've forgotten about making AI inherently more efficient?
So they actually went on eBay and they found a Windows 98 PC.
No way they found one on eBay.
Yeah.
Wow.
A Pentium II with 128 millibit of RAM.
Oh, wow. That's a museum piece.
It's like a museum piece, right? But it's a working computer.
That's amazing.
So the first hurdle was getting this retro machine to work with modern technology.
Right, because good luck trying to connect
Oh, no.
your brand new wireless mouse to that thing.
Right.
There are no USB ports on that.
No.
They had to dig up old PS2 peripherals. You know those ones with the round connectors?
Oh, yeah, with the pins.
Yeah, exactly. The pins that you probably haven't seen in ages.
I know.
And even then, it wasn't easy. The mouse only worked in one specific port.
Really?
Yeah, the keyboard in another. It's like the computer had its own set of rules. Oh, man. I can only imagine how frustrating that would be.
Oh, yeah.
But then the next challenge. How do you get all the necessary files onto this Windows 98 machine?
Right.
We're talking about the large language model, the code to run it. It's not exactly a floppy disk's worth of data.
No, it's not.
So transferring files should be simple, right? But this is 1998 technology.
Yeah, it's not that easy.
They tried everything. Rewritable CDs.
Nope.
The system didn't recognize them. A massive 4 TB USB drive.
Well, forget it. That's way too modern for that old FAT32 file system.
I know.
They hit wall after wall.
So how did they finally crack the code? Did they have to invent a time machine to go back and download it directly from the 90s internet?
They had to dust off a solution that's almost as old as the computer itself.
What's that?
FTP.
FTP.
File Transfer Protocol.
Okay.
It's a classic method for transferring files between computers.
Right.
And thankfully, it still works. So they set up a connection between a modern MacBook
Okay.
and the Windows 98 PC,
Uh-huh.
and boom, problem solved.
I love that.
Sometimes the oldest tricks are the best.
It reminds me of those old adventure games where you have to use these weird, unconventional methods to solve puzzles.
Yeah, exactly.
But even with the files on the computer, they weren't out of the woods yet.
Oh, no.
Turns out they couldn't just run the executable files. They transferred.
What?
There's one more thing to figure out.
Well, love it.
They discovered that the executable files wouldn't run properly until they were transferred in binary mode.
Binary mode.
It's a little technical,
Yeah.
but it has to do with how the computer reads and understands the data.
Okay, interesting. So it wasn't just about getting the files there.
Right.
It was about getting them there in the right format.
Yeah, speaking the computer's language.
Exactly.
So that was fascinating.
Yeah.
But that was just the tip of the iceberg. They still had to get modern code to actually run on this ancient hardware.
Yeah, and that's where things get really interesting.
I know.
So modern code is written with modern computers in mind.
Right.
They tried using a modern compiler. Okay. You can think of it as a translator that turns human-readable code into something a computer can understand. But it was like trying to fit a square peg in a round hole.
Yeah.
That old Pentium II processor just couldn't handle the complex instructions that the modern compiler was giving it.
So they needed a different approach.
Yeah.
A compiler that could speak the language of 1998.
Exactly.
What did they end up using?
They had to go on a hunt for a compiler that was as old as the computer itself.
Oh, wow.
And they found Borland C plus plus 5.02.
Borland C plus 5.02?
It's an integrated development environment, or IDE,
Okay.
released in 1998.
1998.
Ancient history in the tech world.
Wow, an IDE from 1998. It makes you realize how much technology has changed
I know, that's great.
in just a couple of decades.
Yeah.
But hold on, if they're using a compiler that old, wouldn't they have to use an equally old version of C?
Yeah, you would think so, right?
Yeah. Did that cause problems?
Thankfully, the core of the C language hasn't changed too much over the years,
Oh.
which is a lifesaver for them.
Right.
But there was one big difference that tripped them up.
Oh, what was that?
Older versions of C don't let you declare variables just anywhere in your code.
Oh, really?
Yeah, you have to declare them all at the beginning of a function.
Oh, so it's like you have to lay out all your ingredients before you can even start cooking.
Exactly.
That sounds a little restrictive.
It is, but when you're working with vintage tech,
Yeah.
you got to play by its rules.
So they had the hardware, they had the files, and they had a compiler that could bridge the past and the present.
Right.
But they still needed the heart of the operation, the code, for the large language model.
And that's where this prominent AI researcher named Andrej Karpathy comes in.
Okay, I'm intrigued. What did Andrej Karpathy create that was so essential to this project, and how did they manage to adapt it to this ancient Windows 98 setup?
Well, Karpathy developed this really amazing piece of code.
Oh, wow.
It's called llama2.c.
Almaty.
It's about 700 lines of pure C code.
700 lines doesn't sound like much.
I know, right?
Yeah.
But in the world of AI, that's actually incredibly concise and efficient.
Okay.
And the beauty of it is it was designed to run a specific type of AI model
Okay.
called Llama 2.
Llama 2.
And it could work on systems with limited resources.
Perfect for their Windows 98 machine.
Exactly.
So they had the right code, but I'm guessing it wasn't just a simple plug-and-play situation.
And you guessed right. They had to make some adjustments to Karpathy's code.
Okay.
Think of it like tailoring a suit. You have the basic pattern,
Yeah.
but you need to make alterations for the perfect fit.
Right.
They had to replace certain data types, move parts of the code around,
Wow.
even simplify how the AI model was loaded into the computer's memory.
Yeah.
It was a delicate process.
That sounds really intricate.
It was. It was like fine-tuning a musical instrument.
So after all that work, the big question, did it actually work? Did they get a modern AI to run on a computer that's older than some of our listeners?
The moment of truth. And you know what?
Right.
It worked.
No way.
They got a modern AI system using Karpathy's llama2.c code to run on a Windows 98 machine.
That's incredible.
It wasn't super fast,
Right.
but it worked.
So seeing that AI come to life on such an old computer, I bet that was a really rewarding moment for the team.
Oh, absolutely.
But I'm curious, how well did it actually perform?
Yeah.
I mean, we're talking about a 25-year-old computer
Right.
trying to run cutting-edge AI.
It's pretty amazing. They actually shared a table of results,
Oh, cool.
which I thought was really interesting.
Okay.
They tested a few different AI models,
Okay.
each with a different number of parameters.
What are parameters?
Parameters are basically like the brain power of the AI.
All right.
The more parameters, the more complex the model is.
So a model with a lot of parameters would be like a supercomputer compared to a basic calculator.
Right. Exactly.
Okay.
And they measured the performance in terms of tokens per second.
Tokens per second.
Tokens are basically chunks of text.
Oh, okay.
Could be a word, a punctuation mark,
Right.
even just part of a word. And tokens per second tells us how quickly the AI can process and generate text.
So the more tokens per second, the faster the AI can think and respond.
Exactly.
What kind of speeds were they seeing on this vintage hardware?
This is where it gets really interesting. The smallest model they tested,
Yeah.
it's called Stories 260K.
Okay.
It managed to churn out about 39 tokens per second.
That's pretty good for a computer that old.
It's not bad, right?
Okay.
But as you can imagine, the bigger models with millions or even billions of parameters
Yeah.
were significantly slower.
Okay.
One of the larger models could only generate about 1 token per second.
Wow.
And the most complex model they tested,
Yeah.
it crawled along at a fraction of a token per second.
So there's definitely a trade-off between the complexity of the AI model
Right.
and the speed at which it can run on older hardware.
Yeah.
But even though it wasn't breaking any speed records, the fact that it ran at all is incredible.
It is. And it raises an important question. What if we've been too focused on just raw computational power
Yeah.
as the only way to advance AI? This experiment shows that even with limited resources, you can still achieve some amazing things.
It's like proving that you don't need a $1 million race car to enjoy the thrill of driving.
Right?
Sometimes the most exciting journeys happen in the most unexpected vehicles.
I like that.
So if raw power isn't the only answer, what other approaches are there to making AI more accessible and efficient?
That's where EXO's work with BitNet comes in.
BitNet.
BitNet, it's a whole new way of thinking about
Yeah.
how we design and build large language models.
Okay.
And it has the potential to totally revolutionize the field.
Okay, I'm all ears. Tell me everything about BitNet. What makes it so different, and why is EXO so excited about it?
It's all about efficiency. Traditional large language models.
Yeah.
The kind that power those really impressive chat bots and text generators you see.
Yeah.
They rely on what are called full precision weights. Imagine a huge library filled with books, and each book represents a tiny piece of the AI's knowledge. Full precision weights are like having every single word in those books written out in full detail.
So it's like trying to read through a massive encyclopedia to find one tiny fact.
Exactly. But BitNet takes a different approach. Instead of full precision weights, it uses ternary weights. It's like simplifying those books in the library. Instead of writing out every word, you only use 3 symbols.
What kind of symbols?
Think of them like plus, minus, and 0. That's it.
So you're reducing the whole language of the AI down to just 3 basic building blocks.
That's the idea.
That's amazing. But
Yeah.
does that mean the AI is less capable?
That's the really cool part. It's not. By using ternary weights,
Yeah.
BitNet gets incredible efficiency without sacrificing too much accuracy. Remember that 1.6 gigabit hard drive on that Windows 98 machine?
Yeah.
A 7 billion parameter BitNet model would be huge in the world of traditional AI,
Right.
but it could actually fit on that old hard drive.
So you wouldn't need those massive data centers just to store the AI.
Exactly. It's a game changer.
That's incredible.
And it gets even better.
Okay, go on.
Because BitNet is so efficient, it doesn't need those power-hungry GPUs.
GPUs, the things that people use to run AI.
Right, exactly. It can run on a regular CPU like the one in your laptop or your phone.
So with BitNet, you could have AI running on everyday devices.
Think about the possibilities. Imagine having an AI assistant on your phone
Oh, wow.
that can understand your voice commands, generate text, translate languages,
Right.
even help you code. And because BitNet is more efficient,
Yeah.
it's perfect for devices with limited battery life.
It's like we're on the verge of a mobile AI revolution.
I think so. And because BitNet uses less power, it's much better for the environment.
That's great.
Right. EXO is really at the forefront of making AI more accessible for everyone.
Yeah.
They even released a BitNet model for Apple silicon processors.
So they're serious about making this technology widely available.
Oh, yeah, absolutely.
Okay, so BitNet sounds incredible, but still pretty new, right? Is it actually being used anywhere yet?
It is early days, but the potential is huge. Think about all the devices you own that could use an AI assistant.
My phone, my laptop, my watch.
Exactly.
Yeah.
Even your car.
Yeah, BitNet could bring AI to everything.
It really could.
We started this deep dive talking about AI on a Windows 98 machine, a computer that's practically ancient history.
Right.
And now we're talking about a future with AI in all of our devices. It's amazing to see how far we've come.
It really is. It's a testament to human ingenuity and our constant pursuit of progress. The team at EXO showed us that even seemingly impossible challenges can be overcome with creativity and determination. They dared to ask, what if?
Yeah, and they opened up a whole new world of possibilities.
Easily.
And that's what the deep dive is all about, exploring new ideas, challenging assumptions, and making you think differently about the world. So as you go about your day, keep this question in mind. What would you do if you could run a powerful AI on any device you own?
What problems would you solve? What would you create?
Yeah, how would you learn and grow?
The possibilities are limitless.
Until next time, keep exploring, keep questioning, and keep diving deep.
See you next time.